Welcome to SanfordFlipMath. This is PreCalculus. We are working through the Demana Waits Foley Kennedy book, and we are starting what we're going to do a little tiny chunk of Chapter 7, which is about matrices, matrix, plural matrices. And I think for the most part you've seen this before, but I know from year to year coverage of matrices in Algebra 2 varies. You know, sometimes it's there, sometimes it's not. So, and the little unit we're going to do should not be that big of a deal. Most of it's going to be what we do with matrices should be very, I don't know, obvious, I guess, for the most part. So, and until we get to matrix multiplication, and then it's totally out the window, totally bizarre. So anyway, just for those of you new to the plan, a matrix is a rectangular array, which is just another way to say arrangement of numbers. So this is an example of a matrix. These brackets need to be brackets. Just for the record, if you had something like this without the little tails on it, this means something else. It doesn't mean absolute value. It means the determinant of the matrix, and that's a different thing. So that actually means do an operation. It's kind of like absolute value, but it's really not. So just so you're aware, it has to have these little nubbins on the end. Okay, and so they have to be actual brackets. So a matrix is a rectangular array. Every row has to have the same number of elements in it. Every column needs to have the same number of elements in it. You can't have a matrix like 2, 3, 1, and nothing there. Okay, there has to be, it has to be, you know, complete rows, complete columns. Okay, the dimensions are the number of rows. This is a row. This is a row. This is a row. So it has 3 rows. By the number of columns. Okay, so this is a column and this is a column, so there are 2 of those columns. So this is a 3 by 2 matrix. This next matrix that you see here happens to be a square matrix. It's a square matrix because it has 2 rows and it has 2 columns, and since that's the same number, it's square. So you could have a 3 by 3, a 4 by 4, a 5 by 5, a 5 by 5, 6 by 6. You could even have a 1 by 1. Okay, so the dimensions are the number of rows by the number of columns. Okay, there is something called a row matrix, and it's just a matrix that's a single row. So any row matrix will be 1 by something. Okay, so that's just a single row. And in the same way, a column matrix would be a matrix that's a single column. Okay, so it's got to be something by 1. Okay, so just some basic terminology there, no big deal. Okay, okay, moving on. There we go. Did I go too far? There we go. Yes. Okay, you can name a matrix with a capital letter. So we could call this matrix A. Sometimes people put little brackets around the capital letter to make sure it's very clear that it's a matrix. So this is still matrix A. And sometimes you'll see people do the brackets with or without the brackets and put the dimensions there. So that's a 3 by 2. In the same way, you could do a 3 by 2 again without the brackets. So there are different methods, but they're all the same kind of thing. Okay, so we could have a matrix A or a matrix B or matrix C. Okay, so we could have a matrix C that's a 1 by 1, and it's not very exciting, but here it is. That's a matrix C that's 1 by 1. Okay, you can use lowercase letters with the same lowercase letter with subscripts to talk about a specific value in that matrix. So for instance, this one, this says 2, 1, so that would be row 2, column 1. So here's row 2, column 1, and so the number that they're talking about is in this position, and it happens to be 8. Okay, so if you said A 3, 2, well, here's row 3, and here's column 2, so that would be 0. Okay, so that's a way to talk about a specific element. Okay, so if I do lowercase c here, row 1, column 1, that element is 7. Of course, there's only one row and one column, so it's not very exciting. Okay, and then matrices are equal when every single number is equal from matrix to matrix. So for instance, notice this -3 is equal to -3. They're in the same position. They are equal. This 8 is equal to 8. They're in the same position. This 0 is equal to 0. They're in the same position. So for two matrices to be equal, that has to be true. Now what that also does for us is I can say that, oh, if that's true, then 2 has to equal x. And 3 has to equal y. And 4 has to equal 2z, so z must be 2. Okay, so that's basic terminology. We're going to do just a little bit of arithmetic with these, just so we can see what's going on. And we're going to talk about addition and subtraction and scalar multiplication and a little combination of all of that. Now I'm kind of zooming because, again, I think that most of you have seen this before, but you know you are in charge of the pause button. You are in charge of the rewind. You can drag that little slider back and forth all day long, all you want. Okay? Write down what you need to write down. Okay, so matrix addition and subtraction. First of all, matrices must be the same dimensions. So this is a 3 by 2 and a 3 by 2, and they match. So they match exactly, so I can add those. And then what you do is you add or subtract the corresponding elements. So in other words, I'm going to add the row 1 column 1 element to the row 1 column 1 element, and I'm going to get a new row 1 column 1 element. -3 plus -4 is -7. 8 plus -8 is 0. Okay, and this is it. I mean, this is, how hard is this? 3 plus -3 is 0. Well, that's an exciting middle row, isn't it? But you still have to represent it. 4 plus 2 is 6, and then at last 0 plus 7 is 7. Okay, and that is the entire matrix. Okay, same idea for subtraction. Okay, so 2 minus 3, -3 minus -4. Okay, so -3 minus -4 is really -3 plus 4 is 1. 8 minus -8. 3 minus -3. 4 minus 2. And 0 minus 7. Excuse me, sorry about that. Didn't mean to cough in your ear. Okay, one more of those. Okay, so 2 minus 1 would be, now wait a minute. This has 3 rows. This has 2 rows. I can't do that one. Okay, so that it's just not allowed. Okay, there's no way to do 2 minus 1, -3 minus 2, and then what would I do with this 3? I can't do it. There's no 4, I mean, what am I, there's no row down here. Okay, so I can't do anything with that. The dimensions must match in order to be, they have to be the same shape, same number of rows, same number of columns. Okay, fairly intuitive, I think. Okay, let's do one more that's fairly intuitive, and then we'll do some combinations. Okay, now what I want you to notice is this, all 4 of these matrices are the same. So if we were going to add them, we would do 2 plus 2 plus 2 plus 2. Well, 2 plus 2 plus 2 plus 2 is 8. And if I was going to do -3 plus -3 plus -3 plus -3, that would be -12. Well, there is a shorthand for all of this, since they are all the same, and there are 1, 2, 3, 4 of them. You could just multiply by 4. And what you would end up doing is what you would think you would end up doing. You multiply each one of these times 4. Now, I know some of you are going to say distribute, and it's like that, but technically distributing is when you like multiply across addition or subtraction or something like that. That's distributive property. So technically this is not really distributive property, but it is that idea. So I'm going to multiply 4 times 2, 4 times -3, 4 times 8, oops, sorry, 32, 4 times 3, 4 times 4, and 4 times 0, and that's it. This is called scalar multiplication, and the idea is it's like playing with the scale. You know, it's like when we did scale changes on graphs and stuff. So you're multiplying all of the y values by something, that's a scale change. Multiply all the values in here, that's a scale change. So this is called scalar multiplication, or a scalar multiplier. Okay? All right, well, we have done pretty much everything we're going to do in this segment except do a couple of examples. Okay, and this will be the last little run we're going to do. Okay, so typically what I do with this, like on tests and quizzes and stuff, is I'll give you a few matrices and I'll just name them, and then I'll do a bunch of questions based off of those. So notice that this is all about those matrices that you see up there. So that's kind of how I do quizzes and stuff. It's just a lot less typing, and that way we can refer to those same matrices. Okay. So the dimensions of matrix C. Well, there are 2 rows and 1, 2, 3, 4 columns. So this is 2 by 4. Okay. Now, this is one of those times where I think everything on this page you should be able to do. So this is one of those times where if it were me, I would hit pause right now and just do it and see that we get the same exact answer. Okay, and if we don't, then we got a problem. Okay, all right, so hit pause. Welcome back. I'm trusting that you actually hit pause, but you know, that's all good. Okay, this means that we're going to have the first row, the third column. So the first row, the third column, we want the specific element there, and it is 4. Okay, and that's all you need to do with that. You're just identifying that value. Okay. All right, so now we're going to add C plus D. Well, this is a 2 by 4 plus a 2 by 4. Those match, so we can actually do this, and the answer will be a 2 by 4. Okay, and we're just going to add. So -1 plus -1 plus 0. 3 plus -3, 4 plus 5, 2 plus 2. Okay, that's the first row. Okay, second row, first column, second row, first column. 3 plus 4 is 7, 1 plus 9 is 10, 0 plus 6 is 6. And we're done with that. That's it. Okay. So the basic arithmetic stuff is pretty basic, and it's pretty intuitive. So now C minus D. Okay, now pay attention because the signage can be an issue, right? Okay, so -1 minus 0. 3 minus -3. All right, so a little note to self. 3 minus -3 is really 3 plus 3 is 6. I'm not going to do that with everyone. Okay, 4 minus 5. 2 minus 2. -8 minus -1. -8 minus -1, -8 plus 1, -7. 3 minus 4. 1 minus 9. 0 minus 6. Okay, so that's it for that. Got 2 more to go, and then we're out of here. Okay, 3 times matrix D. Okay, I'm just going to scooch this out here so I have a little bit more room. So 3 times, now this is scalar multiplying. Okay, so I'm going to multiply 3 times every one of these. Okay, so 3 times 0, 3 times -3, 3 times 5, 3 times 2, 3 times -1, 3 times 4, 3 times 9, 3 times 6. Okay, that's it for that. Okay, we got 1 more to go. And what you probably, now let me just say it this way. What I would do is do this first. Okay, you're still following the same order of operations that you always have. Please excuse my dear Aunt Sally. Parentheses and other grouping symbols, exponents and other weird functions, multiplication, division together, addition and subtraction together, left to right. So I'm going to do 3 times C first. Okay, so 3 times C, -3, 9, 12, 6, -24, 9, 3, 0. Then we're going to say minus, and the minus is just whatever D is, so I'm just going to recopy D. Oh, can't run the blue into the blue. That's a bad plan, Mr. Sanford. Okay, so let's do this. Okay, so the D is just D. And all I'm doing is rewriting this so I can keep track of what's going on. Okay? All right, so we're just going to subtract these. So negative 3 minus 0. I don't really like that. I'm going to mess things up, but that's all right. Okay, 9 minus negative 3, 12 minus 5, 6 minus 2. Negative 24 minus negative 1. Okay, think about that one. 9 minus 4, 3 minus 9, and 0 minus 6. Okay, so that was the big ugly one out of that. There's nothing earth-shattering in this, and again, it is fairly intuitive. So now the next video will be about matrix multiplication, when you multiply a matrix times a matrix, and that's weird, and so things get a little funky there. All right, well that's it for this first installment from Matrices. Thanks for watching, and we'll see you in class. Matrix multiplication tomorrow, next time. SanfordFlipMath, bye-bye.